To the next technical coding interview questions. The question today says that how two numbers, you're given two non-empty linked lists representing two non-negative integers. The digits are stored in reverse order and each of their nodes contain a single digit. Add the two numbers and return it as a linked list. So you may assume the two numbers do not contain any leading zero except the number 0 itself. So we are given this example 2, 4, 3, 5, 6, 4. Then you have 7, 0, 8, 3, 4, 2, 4, 6, 5. So let's try to understand the question using our umpire approach. First is we have 2, we have 4, and we have 3. And the other is we have 5, we have 6, and we have 4. So, and the digits are stored in reverse order. This is the first value 243 342. So it should be 342 plus 465, just like they are given us there. So how should we go about this question to try to understand it? They have told us that we are given they will be non-empty. Definitely the lengths could be different, and they have also clarified that we cannot have something like 14 or 13 here. That is, we should have a single digit. Okay, let's try to go to the next phase, which is the match phase. Now to match this, we know this is in the domain of linked list, and from previous examples that we have solved before, we can employ using a carry. That is, if you start adding, let's say if you start from we have 2, 4, 3, we have 5, 6, 4. So what we can do is, if we had 3 and 4, we had 3 and 4 from the end, then 4 and 6, then we take the carry to the next one. So now if we start from the end, we can have 3 and 4, 7, 4 and 6, 10, 0, remainder 1, and this gives us 8. But that may be problematic for us because we are starting from the end. Another way for us we can do it, we start from here, the first one, and we build a new linked list. So we take 2 and 5, that gives us 7, and then we take 4 and 6, that gives us 10. We put 0, we carry remainder, we take 3 and 4, that gives us 7 plus 8, and this is what we're supposed to return based on the output. So that's we're already moving to our plan phase now. So that's the plan phase now, the P phase. So we can just begin to do the addition from the head of the list, and we build a new linked list. All right. Okay, that should work. So we're trying to check what are the other things that we need to put in place there. I think that's about all. So we can go to the next phase, which is the implementation stage. Now where we actually write the code, then we come back to the review and the evaluate stage. So we're here now. Okay. So let's go to the coding stage. Let's see. So what we can do is we're going to have return a new head. Let's call it L3. Let's have a L3 4. So this will be the head that will be moving, and we put that as a dummy node. Okay. So we're going to have the notion of a carry. Now our carry will be equal to 0. Then we'll have, while we have something in L1, or if there's something in L2, or if we have a carry, we will iterate through our list. Then we build our so we don't know which of them. If there's something in L1, then what we do is we will take the carry plus equals to the L1.val, and if there's something in L2, we'll take the carry and plus equals to L2.val. So and once we are done with the addition, we will use our L3 dot for next L3 underscore 4, which is the one that we'll make it next, to be equals to our carry divided by 10. So let's say our carry is 11. So by the time we divide it by 10, we are going to have 1 remainder 1. Let's say our carry is 15. By the time we divide it by 10, that will give us 1 remainder 5. Then we will update our carry to be equals to the carry divided by 10, so that the remainder will be carried over to the next. At the end, we will return our help3.next. But here, immediately we have added this, we need to advance our L1 to become L1.next, and we need to advance our L2 to become L2.next. And we also need to advance our L3 to become L3.4 to become L3 underscore 4 dot next. Okay, so we have our code now. We don't know whether it is correct. Well, the next thing is for us to now look through our code and see. So let's copy our code. So we copy our code and we go to here, and we can paste our code here. Sorry about that. That's not what we want. Okay, so we have our code there. Let's also copy. Okay, we have our example, but we can also copy our example, which is this place. We copy our example, we can paste here. Let's see. Paste our example here. Good. All right. Okay, so let's now walk through our example and let's see whether our code is correct. So our L1 is 2, 4, 3, and our L2 is 5, 6, 4. Now by the time we start, we initiate this one, our carry is 0, then so why L1 and L2? So this is the head of our L1. This is the head of our L1, and this is the head of our L2. Why there is L1 or there is L2 or carry? So we know there's L1, there's L2, there's nothing in carry, carry is 0. So what we do, if L1, we update our carry with the val, so carry will become, at this point, carry will become 2, because carry was 0 before, so our carry will become 2 here. Then we advance our L1, so our L1 moves here. Is there L2? Yes. So at that point, our carry will become 2 plus what is L2 dot val. This is 5. So our carry becomes 7 here. Then we advance our L2. It moves there. Okay. Then our L3 dot next, we move from -9. The next will be carry divided by 10. So what is 9 divided by 10? That is 0. So this should actually be remainder. So this should not be division, this should be remainder. So this should be the remainder. Whatever remainder is. So if you divide 9 by 10, it's going to remain 9. And this one will be division. This will be division. We'll update that. So we say carry 9 divided by 10. What's the remainder? The remainder is 9. 2. Okay, so this is 7. So it's 7 here. So 7 divided by 10, the remainder is 7. So this will be 7. So we advance our nests. 3.4. We move here. Then our carry will be 7 divided by 10. That is 0. So our carry still remains 0. There's nothing carry. Then we come here again. Our L1 is 4. So this becomes 4. We advance our L1. So it moves from 4 here. Is there a L2? Yes. So our L2 becomes 4 plus L2 both val, which is 10. So our L2, our carry becomes 10 here. So carry is now 10. We advance our L2. So our L2 moves from 6 to 4. Okay. So and here our L3 underscore 4 next becomes 10 because our carry is 10 divided by 10. What is the remainder? The remainder is 0 because 10 divided by 10 will give us 1, remainder 0. Then we move our next. Then here we say 10 divided by 10, that will give us 1. So our carry becomes 1 here. So we can change our carry here. Our carry here becomes 1. Carry becomes 1. Why L1 or L2? Yes, there's L1. If L1 is 3. So our carry becomes 3. We advance our L1. It moves from 3 to none. If there is L2, yes, our L2 is 4. So we add 4 to the 3. And this gives us 7. Then our L2 moves to none. So both L1 and L2 is now none. Then we divide our L2, our carry, which is 7. We divide our 7 by 10, and the remainder is Yeah, we missed something here. At this point, our carry was already 1 before, then it will be 1 plus our L1.val, which is 3. So that will be 1 plus 3 here because our carry is now 1. So this gives us 4. And by the time we come to L2 is 4. So it will be 4 plus the existing value in the carry, which is 4. So this gives us 8. So here will be 8 divided by 10. The remainder is 8. So this gives us a remainder of 8. Then we advance this to none. Then our carry will become 8 divided by 10, and that will give us 0. So our carry will become 0 here. So automatically this carry has become 0. So this is now 0. So by the time we come here and we say while L1, no L1 is none, while L2, no L2 is none, while carry is 0, then it will exit and come here and it will return the next of these, which is this. So our final value will be 708 to 9. Okay, so let's try and run our code and see whether it works. So let's run our code. So we run, okay, we make the adjustments we needed to make. Which in this case we divide carry divided by carry will be equal to carry divided by 10, and here it is the remainder that we are putting. We just need the remainder of this one. So we just put the remainder there. Okay, so let's run our code and see. We have a problem there. Where's the problem? Oh, int object has no attribute. So we are actually going to form a list node here because we're not supposed to add just a value. So we're supposed to make this a list node. Okay, so let's run it. Yeah, that works fine. So let's submit the whole code and see what we have. Good, so that works pretty well. So let's go back and now check our review. So the review stage now we're in. We've already done the review. We walked through the code, so we're done with the review. Then the next thing is to evaluate. So what is the time complexity of this? The time complexity will be big O of whichever is longer, of L2 or L1. Is big O of L2 or L1, whichever one is longer. What's the space complexity? The space complexity is big O of 1. Big O of, no, because we are using the entire space here. So the space complexity because of the carry, will be big or whatever is greater between L2 or L1 plus carry plus the length of the carry, because if there's no carry it will be shorter, but if there's carry the length will increase by the carry. So the space complexity will be the length of whichever is longer of the two, because we need to keep adding to form the new linked list. Alright, that is it here. Thank you for listening. Do give us a thumb up and please subscribe for the next one. Thank you and see you in the next one.